Hey, welcome back to the College Algebra video of the week. This is number 8. It's an introduction to graphing polynomials. Down here I've given you a few examples of polynomials and their corresponding graphs. And these 4 polynomials and their graphs represent the 4 main end behaviors of polynomials. And when I say end behaviors, I mean what happens as x gets very small and as x gets very big. You'll see on this first graph that our y values increase to infinity as x gets very small and as x gets very big. On this graph down here, you'll notice that our y values go to negative infinity. On this graph up here, you'll notice as x gets very small, our y values get very big. And as our x values get big, our y values go very negative. And on this last graph, as x gets small, our y value goes to negative infinity. And as x gets big, our y value goes to positive infinity. There's an easy way to tell which of these 4 types of end behaviors our polynomial is going to have. It involves looking at the degree of the polynomial, that's the highest power on x in the polynomial, and it involves looking at whether the leading coefficient, that's the coefficient on the term with the highest power in x, look at that number and see if it's positive or negative. So here we have an even degree and a leading coefficient of 1, which is positive. So we get this type of end behavior. Here we have an odd degree, 5, and a negative leading coefficient, that's negative 1. And we get this type of end behavior. Here we have an even degree again, it's 2, and a negative leading coefficient, so we get this type of end behavior. And here we have an odd degree, that's 3, and a positive leading coefficient of positive 1, so we get this type of end behavior. I'm going to summarize all of that information in this end behavior chart. We draw our little pictures of our end behavior, that's the stuff I circled above, and we usually put a little squiggle in the middle to say we don't know what happens in the middle yet. We just know that based on the degree and the leading coefficient, what happens to the polynomial as x gets very small and as x gets very big. So hit pause if you want to take a look at this for a little longer. I'm going to move on and ask the question, what else is important when we're graphing polynomials? Besides knowing the end behavior, it's very important to find the zeros of polynomials. If I go back up to my previous graphs, the zeros of these polynomials are where the polynomials are crossing the x-axis. So each one of these has a 0 in these examples that I've drawn. In some cases, polynomials have no zeros, and in some cases, polynomials have many zeros. So that is probably the next most important thing we're going to look at in this chapter. And to find zeros, factoring becomes very important. Let me give you an example. Here's an example of a polynomial. I could find the end behavior very easily. If I wanted to know where this function crosses the x-axis, or in other words, I wanted to find its zeros, I would just set the polynomial equal to 0, and my goal is to solve for x. Well, it's not easy to do in this form, but if we can factor, it's much easier to solve for x. If we have a bunch of factors multiplied by one another, set equal to 0, what we're allowed to do is we're allowed to split this problem into one piece for each one of its factors. X could be 0, x minus 2 could be 0, or x plus 1 could be 0. That's going to give us 3 different answers. X equals 0, x equals 2, and x equals negative 1. Each one of these is considered to be a 0 of the polynomial, and if we looked at a graph of this polynomial, each one of these zeros would show up on the graph. So this is 0 at x equals 0, there's one at x equals 2, and there's one at x equals negative 1. So the cool thing is, we know where this graph crosses the x-axis, but we also know what the end behavior of this graph looks like. If we look at our little chart above, our end behavior of this graph is going to look something like that. But what happens in the middle in this case is just connecting the dots. Now granted, I don't know how high this graph is going to go or how low this graph is going to go, so there are kind of many options for what this thing will look like. And the picture's starting to get really terrible here. But in general, we have an idea now of what the basic shape of this function is. And if you ever want to know a value of a function, say at x equals 1, you can always take x equals 1, plug it into the original function, and figure out what the y value is. Okay, so to be honest, a big chunk of this chapter is dedicated to figuring out ways of factoring polynomials, just like we did right here, so that we can find the zeros of those polynomials. That doesn't mean this is going to be an easy chapter. It's actually going to be very complicated. But at least now you know the motivation for most of what we're doing in this chapter. Okay, I hope this helps you out. Send me all of your questions, and I'll talk to you soon.